In this video, we are going to discuss about beta-lactamase inhibitors. And what is beta-lactamase? It is an enzyme which creates the beta-lactam ring, which is present in cell membrane of gram-negative bacteria, which makes the penicillin and many of the antibiotic inactive towards gram-negative bacteria. So here we take the example of beta-lactamase inhibitors, that is clavulanic acid. Once if we go to a structure of clavulanic acid, you have a 4-membered ring with nitrogen. After writing this, next to nitrogen, join to oxygen here with a carbon. Join these both to a carbon having a double bond CH, later CH to OH. Here you have salt of acid, that is potassium COO minus. Later this side you have a double bond O and here NH2. This is known as the structure of clavulanic acid. This is similar to that of penicillin. Here you have in penicillin, here you have 2 methyl groups. Instead of 2 methyl groups, here you have CH, CH2OH, and here instead of sulfur you have oxygen. Here with the acyl ring you have a amine group. Now later it is obtained from Streptomyces clavularicis, and later it has a 1-oxapenum structure. This is a basic structure known as 1-oxapenum structure, which lacks 6 acyl amino side chain, which can be seen in penicillin. Here amino group you have some side chain in penicillin that is lacked in this structure, and what it possesses extra is nothing but 2' hydroxy. Why you are calling 2' means at 2 position you have 1', 2'. So at 2' you have OH group. So 2' hydroxyethylene moiety. 2' hydroxyethylene moiety is present, and this drug doesn't have any antibacterial activity, or because it doesn't have any antibacterial, or you can also say as antibiotic activity, which can be seen in penicillin, amoxicillin, and previously discussed antibiotics later, but it is acting as a beta-lactamase inhibitor. It is not having any antibiotic activity, but it is a good beta-lactamase inhibitor. So it is only used to inhibit beta-lactamase enzyme. So what they do is, they take this drug clavulanic acid is mixed with another antibiotic which is inactive towards gram-negative bacteria. So why it is inactive? Due to beta-lactamase enzyme will cleave the lactam ring of that antibiotic. So what they do is they take that antibiotic with a mixture of clavulanic acid. So this clavulanic acid, first it will go and it will make this beta-lactamase inhibitor. Later this amoxicillin will enter into that bacteria. So by mixing the two drugs known as a drug synergism, it will make this it will make this drug amoxicillin active against gram-negative bacteria also. It is used for skin infections, respiratory tract infections, and urinary tract infections. Later it is resistant to acid also, that can be taken orally. Next we will discuss mechanism of action of clavulanic acid, that is how it is inhibiting beta-lactamase enzyme. If you take a beta-lactamase enzyme, on the active side of the enzyme you have two functional groups, mainly the amine group and also the OH group. You have two functional groups, one is the amine group and the OH group, and when clavulanic acid drug will enter, first lone pair or oxygen will go and attack on the carbonyl. This bond shifts here. Here you get a negative, will take this H place and convert it to this structure. If you see oxygen is attached to carbonyl, this bond get cleaved. Here you don't have any that bond. Here it will get negative, taking that hydrogen, convert it to NH. Later the lone pair or amine will come and attack here. This bond will shift towards this, making it C double bond O. This double bond shifts here, making it negative charge. Here you get negative, this will take this H less. So, and after converting, it will convert into this structure. If you can see here, you have NH attached to this. You have a bond between NH and this. NH and this is attached to NH. This bond is lost, so this connectivity is lost. Now later it is converted to NH, NH. This is having CH, COOH. You have NH, NH. This is having CH, COOH. Later you have here, if you see, this bond is this one. It is converted into double bond DO. Here you have a double bond DO because this bond is shifting. Here you get a double bond. So C double bond DO. This is converted into single bond. Here also you have a single bond. CH to CH to OH. CH to CH to OH. In this way it is converted. Later you have a bond between N and H. That one shifts here, become a double bond, and this one shifts. This will take minus, will take this H, and this total moiety will go out. So how you will have? You will have this N with a double bond. You can see here, this one is this nitrogen having double bond, CH, CH. This is attached to a single bond, again CH, NH2. This one C double bond to OH. In this way you have to write. After writing, you have to make it, this hydrogen attached to carbon will shift here, the bond, sigma bond will shift. Later this sigma bond, pi bond electrons will shift first, this sigma bond will shift, pi bonds electrons will shift. Here you will get negative charge, will take this hydrogen and it will lock this enzyme permanently. How it will happen? If you see these whole structures, you have here NH, you will get. Here you get a single bond. Here between these both you have a double bond. Same carbon attached to NH3, carbon attached to NH2. This is attached to C double bond O. In this way it will block the lactamase enzyme. So once it is blocked, it becomes inactive, making this lactamase will become inactive. This is known as a mechanism of action of drug clavulanic acid. This is another beta-lactamase inhibitor, sulbactam. The structure of this will be similar to again penicillin 1. Here you have a 4-membered ring having nitrogen. Next to this you have sulfur, same as penicillin, but here you have 2 oxo groups. So double bond O, double bond O. This is attached to a carbon. These both are joined. Make it a cross. Later you have C double bond O minus Na plus, and next to that you have a double bond O. Here you won't have any chain that you can see in penicillin. This is again a beta-lactamase inhibitor. This is known as numbering. If you give 1, 2, 3, 4, 5, 6, 7. This is 1, 1 dioxo penicillinic acid. Now it is a weak antibacterial activity, but it has a strong beta-lactamase inhibitor. So these beta-lactamase inhibitors doesn't have any antibacterial activity. So this drug is taken in the combination of any antibiotic, just as penicillin. The sulbactam drug with penicillin is available in the market with having the trade name Unacin. So it is used for to treat infections caused in skin, in any tissues, or abdominal infections, mainly caused by gram-negative bacteria. Normally penicillin is active only against gram-positive, but when you take with the combination of sulbactams, which is an beta-lactamase inhibitor, it becomes active against gram-negative bacteria. It is poorly absorbed and not taken orally.